about rotation, reflection, and translations. Last year you did these three. You did rotations, you did reflections, and you did translations. So the vocabulary. A transformation is a general term for 4 specific ways to manipulate the shape of a point, line, or another shape. Today we are going to look at 3 of them. The 3 we're going to look at today are a rotation, which usually is going to be around our origin, and that is simply a turn. Okay, so rotation, that's just turning it. If we are taking a look at a reflection, that means it's kind of like a flip or a mirror image. And then the last one is a translation, is a slide. We're going to take a look at this video. Here we go. And it's pretty short.
Have you ever seen a real live dinosaur or dragon?
Quiet, please.
You haven't, because scientists have determined that dinosaurs lived millions of years ago. And you know that dragons only flared their nostrils and breathed fire in fairy tales. But that doesn't stop animators from trying to bring both creatures to life on film. Using computer animation and motion geometry, artists take dinosaurs and dragons from science and fiction to the screen.
Go behind the scenes to see how the biggest special in Animal Planet history was created.
They transform geometric shapes using translations, or slides, moving a shape from one location to another without changing its orientation, size, or shape. Rotations, or turns, making the figure rotate about a single point or axis along a circle. And reflections, or flips, reflecting one shape to the other side to produce its mirror image. These transformations help artists build the creatures on screen with depth and a sense of motion, making the animals and their worlds look real.
We set out to make dragons as convincing as possible.
Let's have a look.
So our translations are our slides.
Dragons flapping their wings and wagging their tails. Dinosaurs running, fighting, and craning their necks. Does watching all this make you wonder how'd they do that? Creating such detailed moving images on a computer can be broken down to simple geometric shapes and their transformations. How does this dinosaur walk across the earth? The artist uses a translation to create the illusion of movement by shifting a shape from one location to another without changing its shape, size, or orientation. See? The shape, size, and orientation don't change, just the position. The transformation makes it look as though the dinosaur is walking. The same concept applies to the footprints it leaves behind. The artist has created a pattern of footprints by translating each one forward from one location to the next without changing.
So one of the key...
We can replace the footprints with triangles. See how the shape's location changes and nothing else? These transformations reinforce our perception of the dinosaur's motion, and before we know it, have us wrapped up in an animated world that seems real. Another technique of motion geometry that artists and their creatures really couldn't do without is called a rotation, or a turn. These dragons, courting one another by free-falling with feet clasped together, look like they're rotating in the air. That's because artists move the shapes that make up the dragons about an axis, creating the perception that they're actually spinning. See? Each simple shape rotates along a circle, around the axis. In geometry, a rotation changes the orientation of a shape, but not its size. A flip probably makes you think of this kind of flip. But the term flip in geometry refers to producing a shape's mirror image, its reflection. In the world of computer animation, artists flip geometric shapes all the time. Looking at this early computer creation of a dinosaur, you can see that one side is the mirror image of the other. The shapes don't change, but their location and orientation do. They've been reflected to the other side. Can you visualize the reflection used to create this dragon's wings? Look closely. One can be made using the mirror image of the other, the one shape reflected over to the other side. Let's flip or make reflections of these shapes. Look at each reflection. The shape's form and size is the same. We just change its location and its orientation by flipping it over. But notice that the square and circle still look the same. That's because they have a flip within their shape. See? We can cut them in half, and the halves are mirror images. They're symmetrical. Animators use these transitions all the time.
So once all these elements are combined, hopefully you will believe that you are seeing real dragons.
Realistic dragons and real-looking dinosaurs, thanks to motion geometry.
Mirror images, they're reflected over a line called our line of symmetry. If we look at this line of symmetry, it's kind of like the horizon. Reflections can be found all over the places. Here is a mountain reflected on a lake. The snowy part is actually reflected. It says every point if we are looking at this, so this is where you're starting to fill in your notes. Every point is in this case, we are going to put the same distance from the line or the shoreline. And the reflection has the same size as the original shape. So if we're looking at other things that we notice, if you were going to say other things that you've noticed, please right now take a minute and check. Everything is reflected. What? Everything is reflected, right? All the hillside, all the stuff. Some you can see better than others, so everything is reflected. Yeah. What's that? It is like turning it around 180, like a turn of 180 degrees. Okay, so a reflection, kind of like a turn of turning it around 180 degrees. We're looking at it that way. So we're going to talk about rotations on the top of the next page also. So we got reflections that we kind of talked a little. We're going to look at today rotations. So it says a pinwheel shown has a green obtuse triangle, so that's this triangle right here. This is an obtuse triangle that has been rotated around the center in a counterclockwise, right? So counterclockwise, meaning going the opposite direction, like instead of going from 12, 1, 2, that's going clockwise this way. This is counterclockwise, right? So counterclockwise direction several times. This is an example of a rotation. The angle of rotation, which is the angle that is turned by the figure, around a center point. You could use a protractor to measure this, but if we notice that it is a circle going 360 degrees, how many triangles do we have? How many triangles do we have going around here? 8. So we could take 360 and we could divide it by 8, which means the angle is how many degrees? So 360 divided by 8, 45 degrees, right? So this angle of rotation is a 45-degree rotation. So in your homework, if you are asked, Jack, did you write this down? In your homework, if you're asked to find the angle of rotation, you need to find how many times it rotates. And you take, because around this one point, that's 360 degrees, just wait. So it says, does this windmill show rotational symmetry if we are looking? Going from here to here. Or if we are going this way, right, going counterclockwise. So clockwise, or we're going counterclockwise in this case, or going clockwise. So does it show rotation? We'd say yes. What is our angle of rotation? Well, this time we want to take 360, and we have how many? Because going around the circle, there's 360 degrees. And how many times does it look like it rotates around this one center point? So we're going to take 360 and divide it by 4, which gives us a 90-degree rotation. We're going to talk about the 90-degree either being positive or negative 90, depending on if you go clockwise or counterclockwise. And it says how many times is this figure rotated? And we should have had the 4 times. Right? So make sure you fill those in. Someone said, well, could it be 3 times? But if you go 4, then it takes you back to the original. Right? So like 3, because it's just going to those other 3 and not back to the original. All right. So let's take a look at translations. Translations. If you make a strip or a pattern on a wallpaper design, it requires a series of drawing and moving steps. You draw the basic element or design, then you slide it to a new position, and you repeat that same pattern or element. Says you slide it the same way to a new position, you repeat the element again, and so on and so on. The slide is what we call, to the next one is called the translation. So you are going to always be asked to describe a translation. You need to specify the distance and the direction. So in this case, if we're looking at these bikes, we would say that it moves down to the right. And we could easily set a protractor or a ruler, and we could measure that distance, right? So we could say, oh, when we look at this, it looks like it moved like so many centimeters, okay? So like this one might move 2.2 centimeters, and we would say it moved down. Please write this down, some of you that aren't writing. Down to the right, okay? So we're telling it the distance, that's the how many centimeters, and we're telling it the direction, down to the right. If you think of this picture of this scene where you have just this one scene, this is moving to the right, right? Or it could be moving to the left depending on where you started, okay? So as you look at these pictures, that's kind of what they're wanting you to think about when we do our translations. Our translations are going to be more on a coordinate grid. So as you take a look at this next one, it says if we are going to reflect hexagon A, B, C, D over line M. Reflecting a figure over a line is a geometric operation called a transformation. You're transforming, copying the image of the original into the new position. When we name it, you're going to notice that we put these little tick marks, okay? That's for calling it prime. So we don't call it A tick mark, we call it A prime, B prime, C prime. So if I am looking at this, I want to get B about the same distance away from where B is to this line, and we're going to call this new point B prime. Just draw this. Yep, you want to draw. Now you want to take, and you want to go, oh, I think D is about right here, and we're going to measure that. We're going to call it D prime. Could we actually put a ruler on here and measure each of these? Yes. We're going to be doing it more in a coordinate grid, so you won't be doing ones quite like this. But do the same for point C, right? We want to call it C prime. Do the same for point A. We're going to call that our A prime and E prime. So that if you are looking at yours, and it doesn't have to be exact, but you're going to have each of these points. And each time we do a new point, what we're going to call it is A prime, B prime, C prime, D prime. So notice your C is just the opposite. So it has to go in. So how this goes in towards, we call that, going in towards, this has to also. So you are not sliding it over. It should not be like you slid it across. You are reflecting it. So as we look at question 1 here, it says, compare the lengths of the line segments in the original and the image. Meaning, if I take a measure from E to D, and if I am measuring that, and I notice that, oh, that is 12 centimeters, and I go over here and I measure, and it's exactly 12 centimeters. Okay? So I have 12 centimeters in each of those. What do you think is going to happen if I measure from E to A, and then I measure from A prime to E prime? Do you think they should be the same distance? So we think that this should be exactly equal to this side. We would think that from AB to A prime, B prime, that those would be the same if we drew it very accurately. So it says compare the lengths of the line segments in the original and the image of the copy. They should be all the same length, meaning AB, that length, is going to be equal to A prime, B prime. Notice I don't have a segment over the top, and you shouldn't either when you write this, because we are talking about a distance, not a line segment. We're talking about its distance, okay, or its length. If we compare the measures of the angles, this looks like a 90-degree angle, this looks like a 90-degree angle. If we're measuring this angle, this one should look the same. So if we would compare the angles going around our original figure, all the original, please write down, and image angles are equal. Meaning angle A is going to be, this is the symbol that we use for equal or congruent. So if we say the measure of angle A is equal to the measure of angle A prime. We could write that for B prime and C prime and for each one of them. So if we're going to write one more of these saying that the angle is congruent or equal, we could say the measure of angle E is going to be equal to the measure of angle E prime. The notation, this M is telling us measure. This is telling us of our angle, so that's our angle symbol. They talked about in the reading up above that this is for the A prime, B prime, C prime when you're looking at that. So just talking about those angles. As you look at that next page, that next part of your notes, we are taking a look and it says, what types of transformations do you see in the pictures below? So what we want to put by each one is you want to write the word reflection, rotation, or translation. So translation, rotation, or reflection. And we want to draw the line of symmetry if it is a reflection. So you'll draw a line of symmetry. If it's a rotation, we need to find the center and we need to find the angle that it rotates. If it's a translation, we want to tell the direction and how far. So we are going to start off with the butterfly. If we are looking at the butterfly, would you say reflection, rotation, or translation, Cassie? Reflection. Reflection. So you're going to write that down either above or below it, reflection. And now we need to draw a line of symmetry. Is there more than one line of symmetry for this one?
Yes. No.
There is? Yeah.
No.
Should be just one, and it should be the vertical, right? Meaning if I'm looking at going from here, right, this line, do you agree? You cannot draw a horizontal one because this part of the wing does not match up to down here. So you can only draw the one line. So if it's a reflection one, you're going to draw that line of reflection, okay? So please draw that line in. If you are looking at the circle one, that next one, that going around, it's kind of like a fan, we would say that that one is a rotation. Now, if it's a rotation, we need to tell the angle and we need to say where the center is. Obviously, the center is right here. So that's our center. And how many degrees is it rotating to get from this point right here to over here? So we have how many of those fans? Three of them. So to find the angle of rotation, we are going to take 360 and we are going to divide it by 3, which gives us 120 degrees. So our rotation is 120 degree rotation. Draw those, put the lines in. And the center, you want to make sure you see that one. This last one down here is going to be our translation. And all of these pictures are, our homework is going to be a lot more looking like this as we get into the unit. But in this first one, we're translating the fish, and we could either say, are we moving it, could we move it to the left or to the right? Does it matter? No. So if we start as this is our original, if this is our original picture, right? Going around this fish. If this is our original, then we would say the translation is moving it to the left. And now all you need to do is measure this distance to here. And you might say it moves to the left 5 centimeters or 3 centimeters or however far that happens to be. Okay? I would like you right now looking at the other 3 that are on this picture to put the word that goes with them and then kind of check with your. So if we are looking at this one, we have a rotation. And we are going, and it doesn't matter if you think of taking this point and going here with the arrow, or if you go this way. This would be our center, right? So this is our center of our rotation. And Ella, what would we say? How many degrees? One way or the other. How about if we're going right from this point, here up to here? How many degrees do you have here? 90 degrees. Okay? So by looking at that angle that it turns, the angle right here, right? This is a 90 degree. If I am looking at this picture, rotation, reflection, translation. This picture over here. Reflection. If it's a reflection, we now need to tell where that line is.
The line in the middle.
And it is
The line.
the x-axis, right? So please make sure you extend that line so you can see it. The last one that we are looking at, this is our translation. That's a slide. And I want you to picture, how did you move point B? How many places did you move it over? So we are going to say we move it how far to the right?
6.
So we're going to move it 6 places to the right, 6 units to the right. And then how far did we move it down?
3.
And down 3 units. Okay. You're going to be doing more problems like these as we start the lesson today. The assignment is pretty easy that you are taking a look at. So as you are taking a look at this, I know, I'm going to get you your workbook. So, I have a few of you that still need to take your tests.